if not familiar with Fortran, so it's integer 4 is a 32-bit integer, okay, and so because the value of IST and IN depends on value of my rank, okay. So if you have a core count larger than 4096, if you time it, so my rank plus 1 times chunk size. So this is larger than what a 4-byte integer can hold. Okay, so actually you have an integer overflow here. So this is if you have something like this, you don't program. And again, I mean, this is not very likely because, like I said, I mean, it's most likely that I have a fixed problem size. But if for some reason somehow you have this in your code, okay, it will run perfectly fine until you hit that specific core count and beyond, right? So, it definitely not a good thing to have something like this in your program, right? But this could happen because now probably you use 8-byte integer or whatever, but I think a lot of us have to deal with like the legacy code and stuff like that. So a lot of this kind of thing could happen with old code. So just a little example. So you see that something you take for granted for a serial program or a parallel, a small core count parallel program. We'll run it with a small core count, but something that could happen with a large core count. So if you have something like this, it would be very, very difficult to debug, right? Okay. So now, what kind of tools we have at proposal to help us with if I ever have something like this? Okay. Well, for every debugging class, these two commands will be mentioned, right? Write or printf. So I think I guess every programmer does write or printf to find out what the value of a variable when something went wrong, right? It very easy to use, and the most important advantage of this is it's the most important way of doing things, right? I mean, it's because it's a part of the language. Okay, so it's very easy to use, very attractive, but well, there are a few disadvantages that because of those you shouldn't use that very frequently. Use this type of this matter of debugging very frequently. Okay, because to use these to use write or printf, you need to edit and recompile your code every time when you want additional information. Okay, and also it may change the program behavior because you're adding statements in your program. Okay, and it's only capable of it can only print a certain range of things, right? I mean, so it's not it cannot review a whole lot of information to you. And also, I'm not sure if any of you guys try to do this with say 8 or 16 or 32 words. The size of the output. Okay, you probably need like a parser or something just to find the useful information out of the output you got from the screen out. Okay, so not very this is something like everybody knows you need to write annotation in your program. Okay, you need to say what this subroutine does and what that subroutine does. Everybody hates doing that, right? I mean, it's just why should do that? But it's just exactly the same thing, right? I mean, it's just it's just a form of habit to for good programming practice. So of course it's not recommended, and compilers can help. I think Galen mentioned this morning. Actually, the web page Galen mentioned this morning is a good source of information. So compilers, well, most compilers can. I said runtime here, but actually at both compilation time and runtime, it can help you with certain aspects of debugging. Okay, it can check the array bound is overstepped, and it can trap the floating operation exceptions like divided by 0 or have a square root of a negative number, overflow, underflow, that sort of things. And also, it can provide traceback information when the program crashes. The problem with debugging with compiler is again, it's limited capability. Okay, it's only a certain number of things that compilers can help you with. Okay, and it's non-interactive. Okay, so what I would normally, what I do is I probably have a make file, and then I have a set of options. So I have a target with all the optimization flags, and also at the same time I have a target debug. Okay, with all the the debugging options turned on. So basically, every time I write something new, I make the debug version and then let the compilers check for errors. Okay. So finally, debuggers. Okay. So the parallel debuggers, of course, they're capable of doing whatever a serial debugger can do. Control the execution for a program and setting action points and view and edit the values of the variables, and also to help you debug a parallel program, it needs to be able to control the program execution at various levels. It should be able to control the execution of a group of processes or threads or individual process or threads. Okay, so basically it needs to be flexible when it comes to controlling execution, and also it needs to be able to review the communication status to users. Okay, so for a good parallel debugger, it should allow you to control the execution, the control of execution pretty easily, and also it needs to be portable. Okay, so it needs to be available on, because now I guess most of us run programs on multiple platforms, so different platforms. So it should support multiple HPC platforms. Also, it should be scalable. It should be able to allow you to debug a program with say 4 processes, and it should be able to it should be able to allow you to debug a program with 1,000 processes. Well, that is probably a little bit greedy, but this, like I said, this is the ideal debugger. What an ideal debugger should do. Okay, so how parallel debuggers work? So basically, you have a front end. Okay, this is run on the interactive node. It's probably not the login node of the cluster. It's probably the master node of your interactive job session. Okay, so you have a front end which has a has a GUI, and also it has a debugger engine which is like that controls all the debugging agents on individual nodes. Okay, so there are agents running on each compute node to control your application, and it will collect sample data and send it back to the engine to process, and basically it will present the information to user through the GUI, or some debugger not have the GUI, or you can opt to not using it. But so this is what this is how a parallel debugger works in general. Okay, so why we need to know this? Because you need to be aware that if you debug a parallel program which is running with thousands of cores or a large number of cores, the debugger itself becomes a large parallel application. Okay, so you can do certain things like now we have a one level structure here, so you can do certain things like put agents, intermediate agents to alleviate the the usage of network and so on. But if the core count is large enough, there will be considerable overhead with the debugger itself. Okay, so just to list a number of things here. You can have a startup cost and communication and between the front end and agents. Okay, so the data the volume of data needs to be collected by the agent and sent back to the front end of the debugger. It could easily cause network congestion. Okay, well, if you want to try this, you can try to start a debugging session with say 256 cores, and then try to let all the processes step from one line to another, and see what happens. Okay, so it will take quite a while for that to complete. And also when it's have a very large core count, if we will try to debug a program with a very large core count, the access to shared resources. If you say your executable is on an FS file system, it could cause significant overhead. Okay, so now basically, when you're debugging a parallel program, okay, now you're actually running two parallel applications at the same time. Okay, so no matter what there's a lot of efforts that try to make reduce overhead and all that, but again, need to be aware that you're running another large parallel application. Okay, so there will be problem with that. Okay, actually, I'm not sure where I should put this slide, but I think Rebecca mentioned this. So when she was talking about the exercise problem, so validation is crucial. Okay, so when you write a program, so if it crashes or hangs or anything like that, you can tell pretty easily, right? But how do you know that your result is correct? Okay, you need to think about this before you start writing your program. Okay, so you need to have a validation procedure. Okay, so you can check the result with an analytical solution, maybe, right? In some cases, or you can visualize your result and see if there's any kind of artifact there, right? Also, or you can have a a few test cases where the answer is no. Okay, so when you increase the core count, you increase the scale of your program, you can still run those cases against those cases and check the result. Okay, to check the correctness. Okay, because it's very, very bad to have a large application running with thousands of cores giving you nonsense, right? And even worse, you probably don't know, right? So it's very crucial. So this is not part of a debugger, right? As any debugger can tell you the correctness of your program. Okay, so this is something that as a programmer yourself need to do. Okay, so I have a few slides about the general debugging strategy when you debug a parallel program. Okay, so basically this is kind of like common sense. So downscale if it is all possible. Okay, so you want to debug a program with the smallest scale, okay, possible. The number of processes, the size of the problem, and so if you can reproduce a problem, say with 2 processes, right, go for it, right? It will be easier to debug with say 16 processes, okay? And extreme example is if you can run it with 1 process or 1 thread, you can do that.